Hello, in this video we're going to look at how to find an angle using the sine ratio. Again, this example specifically tells you to use the sine ratio, but whether you're finding an angle using cos, sine, or tan, it's the same principle. The only difference is figuring out which one of those primary trig ratios to use, and that's based on the sides that are given to you. So in each of these cases, since I'm using the sine ratio, we know that sine of some angle is equal to the opposite over the hypotenuse. So each of these cases we're given the opposite in the hypotenuse. So I want to find sine of t first and then use that to find the angle t. So we see t, the opposite is 5 and the hypotenuse is 11. So sine of angle t is equal to the opposite, which is 5, divided by the hypotenuse, which is 11. Now one nice little check you can do here, and this is really a nice idea, is we know that the hypotenuse is always the longest side. So you should always get a proper fraction. Now for those of you that don't remember, a proper fraction is a fraction where the denominator is larger than the numerator. It's a value less than 1. So that's a nice thing to remember. This is going to be actually a very important idea moving forward. So to solve for t, so this is the sine ratio, pardon me. To solve for t, I need to get it by itself. So in mathematics, we perform the inverse operation to undo a specific operation. So if I have addition, I apply subtraction. Multiplication, I apply division. With trig function or trig ratios, it looks a little different. So if I want to apply the inverse sign, the step I could do, but I don't typically show, is this. To take the sine inverse, we write this. Sine inverse sine t is equal to, now we have to take the sine inverse of this side. So this is a step we typically don't show, but what I've done is I've taken the inverse sine of both sides. Don't say sine to the negative 1. Again, do not say sine to the negative 1. That is incorrect. This is said sine inverse. So if I take the sine inverse of both sides, I'm simply left with t on the left-hand side. We can demonstrate this quite nicely on my calculator. Watch when I do this. So I'm going to take a sine, which is sine inverse on my calculator, sine of 30. And when I hit equals, I'm left with 30 because sine inverse of sine of 30, the sine inverse and sine are inverse operations, so they cancel each other out. So t is equal to sine inverse of 5 over 11. So t is approximately equal to, and now I've already checked and I know my calculator is in degrees mode, so I'm going to take sine inverse of 5 divided by 11 equals, and I get approximately 27 degrees. Don't forget that degree symbol. If I don't put the degree symbol, I'm talking in radians, which is not the units I'm interested in. So let's do this next example. So here's t. 4 is the opposite. 20 is the hypotenuse. So sine of t is equal to 4 divided by 20. Again, my little check here is that since the hypotenuse always has to be the longest side, the denominator should be larger than the numerator. So that works. And in fact, if you watch what happens if I did this. Sorry, let's just take a second here. Watch. This is a common mistake that students would make. Sine of t, and they do this, 20 over 4. And then they would say, so t is equal to the sine inverse of 20 over 4. This is what some students might do. So for reasons that we're not going to explore right now, but this is something to think about when you leave this video. If I try and do this, 20 divided by 4, my calculator gives me an error. So it won't work. And the reason why it won't work is because the hypotenuse is never going to be smaller than the opposite. And we explore that concept in greater detail a little later. So remember, this is incorrect. So let's come back over here. So t is equal to the sine inverse of 4 over 20. Again, I want to be sure I type this in my calculator in one go. I don't want to write 4 over 20 and then approximate that as a decimal, even though 4 over 20 is a pretty nice decimal. So I'm going to take sine inverse of 4 divided by 20, close my bracket, and so I get t is approximately 12 degrees. Which I feel good about because 20 is so much larger than 4, this angle t should be pretty small. I hope that helped.